Hi everyone, I'm Lynnea Olivarez, Chair of ASGCT's Communications Committee, and you're listening to Soundbites of the annual meeting, our mini podcast series recorded live here at ASGCT 2025 in New Orleans. Joining me now is Dr. PJ Brooks, Deputy Director of the Division of Rare Diseases Research Innovation at the National Center for Advancing Translational Sciences, or NCATS at NIH. Dr. Brooks, welcome.
Great to be here, Lynnea. Thank you.
You're part of a fascinating session yesterday exploring how CGT developers can navigate the unique funding challenges in our field. Can you share a few key takeaways from your talk, especially the role of federal agencies like NIH in advancing early stage innovation?
Sure. I think, a lot of what we focus on in the cell and gene therapy space are projects that are trying to find ways to develop gene therapy and gene editing as therapeutic platforms to address multiple diseases. And in the Division of Rare Disease Research Innovation, where I work, we're well aware of the fact that there are close to 10,000 or so rare diseases, and about 80% of them are monogenic, and at least in principle could be addressed by gene therapy or gene editing. But a big fraction of them are so rare that there's no commercial interest. So one approach to getting to all those patients who could benefit from these therapies is to develop them as therapeutic platforms. And a lot of the projects that we are involved with are doing that. Those include the Platform Vector Gene Therapies program from NCATS with NHGRI and NINDS, the Bespoke Gene Therapy Consortium that ASG is also involved with, and we're going to be talking about that in the session this afternoon. And also the somatic cell genome editing program that is very specifically focused and indeed in some cases requires investigators to develop a clinical program focused on one editor, one delivery system, but more than one disease, and to explore the regulatory pathway through formal FDA interactions and disseminating that information throughout the consortium and ultimately to the community.
And all in all, like you mentioned a few of these programs, the Bespoke Gene Therapy Consortium, you're also involved in initiatives like the PAVE-GT.
Yeah.
And big picture, how are you reimagining what's possible for rare disease treatment?
Yeah, I can imagine what it would be like. I think what we're really seeing as a therapeutic platform emerging is particularly genome editing, with the idea that, as I was saying, that we're looking at an editor and a delivery system and applying that to more than one disease, potentially by changing the guide RNA. And I think we saw an exciting glimpse of the potential of that from the work that was presented by Karen Musunuro and Becca Ahrens-Nicholas, both of whom are part of the SCEG program and have one of these grants, and how they were rapidly able to develop a genome editing treatment for a little baby named KJ. And it's interesting looking at the way people are responding to that. There's a great focus of it being an N of one story, which I see it a bit differently. I would like to see it as the first step in developing a therapeutic platform around that approach for gene editing for the treatment of metabolic diseases to the liver. So I think that's where I hope we'll be able to go in the future, and that's what the projects are funded towards. And I think that approach makes a lot of scientific sense. The business model around it is not so clear to me, and it's not my area I'm particularly knowledgeable about or particularly my job, but I think what we can do through the SCG and some of these other programs is to demonstrate the potential of what can be done and explore some of these novel therapeutic platforms and the regulatory pathways for them. And with regard to the BGTC and PAVE-GT, that's another focus of those efforts, where we're really trying to capitalize on the platform capacity of AAV as a gene therapy vector And as we go through the regulatory interactions with the FDA, with a continued effort on trying to identify the most efficient ways to get into clinical trials, using that information and disseminating through the community. So we're both trying to sort of lower the bar to getting to the first in human trials, and also disseminating what we've learned so that other people can hopefully follow in what is a more efficient pathway.
And finally, with everything that you've seen across the NIH and beyond, what are you most looking forward to? What gives you the most hope right now for the future of the CGT field?
I think certainly the work with KJ and the realization that some of these things can be done very efficiently, and really building upon those where you have a good delivery system for a tissue. And we clearly have that for the liver, but we would, to extend that approach to other tissues, we need better delivery systems. And one area of great interest is the central nervous system. Some work we funded through an earlier phase of the SCEG with Ben Deverman. He was able to develop a variant of AAV that efficiently crosses the blood-brain barrier. It's now being used in a later SCEG project with Sonia Valab to treat prion disease. And that area, that general approach, has really exploded at this meeting very quickly over the last couple of years. But we're also very excited about other and better delivery systems. So we have a prize competition through the SCEG where we're actually given prizes for delivery vehicles for genome editors that can be that are programmable to go to specific cells and tissues, or non-viral approaches that can cross the blood-brain barrier. And I think some of these non-viral approaches are potentially very exciting because they may be less expensive to develop and less immunogenic and less toxic. And we certainly saw that with the work with KJ that Becca and Kieran did. So I think those are all very exciting on the technology front. I think something that is going on outside of the NIH that's intriguing and potentially exciting is an effort in the United Kingdom, what is called the Rare Therapies Launchpad, where they're planning to sort of pilot the idea of a regulatory process that would approve what they call a center of excellence to do treatments for multiple diseases using the same modality within strictly defined limits, but in a way that wouldn't require the investigators to come back to the regulatory agency every time they want to do a new disease. And the idea that they have around that is that that's something that could potentially lead to a pathway that would be reimbursable. And I think it'll be very interesting to see how that develops in the UK. I have no idea about the potential of that in the United States. Scientifically, I think we could do it. But the other issues around that are, again, well above my pay grade and capacity to influence. But I think what we can demonstrate through NIH funding is, what is possible and some of the real benefits of doing this. And the work with KJ is a great example of that. We certainly hope to see more of those through that program, and the BGTC and PAVE-GT as well.
Fantastic. Thank you so much for joining us today, Dr. Brooks, and thank you for your leadership in advancing research for rare diseases and gene therapies alike. So stay tuned for more sound bites of the annual meeting from ASGCT 2025.